position, velocity, and acceleration, PVA, with speed. Let x of t be the position of an object on the x-axis. Then we have the following definitions. V, the velocity, equals x prime of t. The speed is the magnitude of velocity, or in one dimension, the absolute value of velocity. And a, the acceleration, is the second derivative of position, or the first derivative of velocity. So a is x double prime, or v prime of t. Let's do a simple example. Consider an object which moves along the x-axis such that its position, t greater than or equal to 0, is given by x of t equals t cubed minus 15 halves t squared plus 12t. Let's find the velocity and acceleration equations. Well, v of t is the derivative of position, which equals 3t squared minus 15t plus 12. And I'm going to go ahead and simplify this a little bit. Let's start by factoring out the 3. So we get 3 times t squared minus 5t plus 4, which equals 3 times t minus 1 times t minus 4. Come back to that in just a bit. Now let's find the acceleration, which is the second derivative of position, or the derivative of velocity. And I'll look at this version here to get it. It is 6t minus 15. So what is the speed at, say, t equals 2? Well, the speed is the magnitude or absolute value of velocity. So the speed at 2 is the absolute value of the velocity at 2. So if I plug in, I get the absolute value of 3 times 2 minus 1 times 2 minus 4, which gives me a speed of 6. For part C, I want to find when, say, the velocity is positive, but the acceleration is negative. That's why I wanted that factored form. So I'm going to build some sign charts, but I'm going to put 2 sign charts, say, right on top of each other to help me see this. I'll put velocity here, acceleration there, and I know I start at t equals 0 because the problem said t greater than or equal to 0. I will now put the zeros of my velocity, 1 and 4, and then I'll put the 0 of acceleration, which is 15 over 6, or if I divide everything by 3, 5 over 2. Now let's do some sign charts. I'm going to plug in t equals, say, a half into velocity. I get negative times negative. This gives me positive. If I plug in t equals 2, I get positive times negative. If I plug in t equals 5, I get positive times positive. For acceleration, if I plug in t equals 1 into acceleration up here, I get negative. And if I plug in a number, say, t equals 4 into my acceleration, I get positive. So when is velocity positive but acceleration negative? Well, I can look pretty easily on my chart here. It's only this first interval for t between 0 and 1. Let me rewrite the velocity down here in factored form. We have 3 times t minus 1 times t minus 4. Now let's use this for part D to interpret the motion of the object. So when we are interpreting the motion of something, generally speaking, I'm looking at velocity. And so what I want to find out here when I say interpret the motion is, since I'm on the x-axis, the object is either moving right, moving left, or stopped. So how do we know when the object is moving to the right? If I plug in some values, or at least place some values down here, like if this was a number line, I notice that if we're moving right, x is increasing. So if x is increasing, I know its derivative, which is velocity, must be positive. And so if I look at my sign chart up here, I could say that we're moving right on the interval 0 to 1, along with 4 to infinity. When is an object moving left? Well, an object is moving left means that our x values are decreasing. But if something is decreasing, then its derivative, which in this case is velocity, is negative. And if I look back up at my sign chart for velocity, I see this occurs on the interval 1 to 4. So the object starts by going right, then goes left for a bit, then goes right again, and of course, in between those times, it is stopped, at least briefly. So when is something stopped? Well, when its velocity is 0, and that's at t equals 1 and t equals 4. Very quickly, I could have said y of t is the position on the y-axis. So instead of moving left and right, pretend we have an object that's moving up and down. So how do we know when an object is moving up? Well, let's do a similar thing. Let's say that's 0 on the y-axis, 1, 2, etc. When is something moving up? Well, I know that the y values are increasing, which means its derivative, because if anything is increasing, its derivative, in this case we can call velocity still, is positive. When would the object be moving down? Well, if the object is moving down, then the y values are decreasing, which means the derivative of y, which happens to be velocity, is negative, and of course you're stopped when the velocity is 0.